Equidistant from 1 minus 2 and x equals 0. Let's mark off the point 1 minus 2 then, which we can put here. 1 minus 2. The line x equals 0 is simply the y-axis. That's our directrix then, isn't it? There. So we know, now we can see where the axis of the parabola is. It actually goes through this point here, doesn't it? There's our axes. So we can draw our parabola then. It comes from here, halfway between, and it has to go around here, doesn't it, like so. And the same the other side. So I'll just put dashes in, because I'm not particularly good at the sketch sometimes, so that'll be helpful here. So there it is, it's symmetric about this axis here. So let's mark off a general point P and label that xy. Then this distance here to the focus, so down here, this distance will be the same distance as if you drop a vertical to the directrix there. So let's have a look at that then. So here let's write down the condition. What have we got? We've got this distance is equal to that distance. So this triangle squared will equal this distance squared. So this length squared is x minus 1 squared, that's the x distance, and the y distance is y. Take away minus 2, which is y plus 2, squared, is equal to this distance here, which is simply a horizontal line of distance from x to 0, which is x squared. So, what have we got then? The x squareds will cancel. Leave the y plus 2 as it is. The x squareds will cancel when we expand this bracket. There'll be a minus 2x comes across to be plus 2x. There'll be a 1. Minus 1 squared is 1. Move that across to minus 1. So we get y plus 2 squared equals 2x minus a half, isn't it? So that's what we get. And we can just verify that we've got our vertex here. That should be halfway between. This vertex should be the point when we get x equals a half. It's halfway between 1 and 0. And the value minus 2. That's the vertex there. So when you put in x as half, you can see that side will be 0. When you put y as minus 2, you'll get 0. So yeah, that does lie on the curve. So that looks good.